Good morning or good afternoon or wherever you are, and welcome to day 3, session 2 of the 2024 Virtual National Work Zone Management Conference. This one is Proven Safety Countermeasures for Work Zones. We've got a fantastic panel up ahead of us. Quick note, housekeeping note, if this is your first session, you're joining us today. Remember, if you would like to ask any questions of our panelists, or if you have any technical issues, please type them into the question and answer box, which is over in your console. That is your best way to reach us at any time. So just throwing that out to you. And now, without further ado, I'd like to introduce you to our moderator and fearless leader for this session. Beth McNeil Stinson serves as ARTBA's Vice President of Educational Operations. Beth has over 30 years of experience in adult education, instructional design, and project management, building and teaching face-to-face, hybrid, and fully online programs. She's worked at 7 colleges and universities, 2 software companies, and a defense contractor, designing smart classrooms, software, job aids, and instructional materials to support teaching and learning. So Beth, take us away.
Thank you so much, Matt. We have 3 panelists today, and I'm going to introduce all of them together, and then they will each speak in turn. So our first speaker is Phil Bobbins. He is the safety engineer in FHWA's headquarters of safety. He is responsible for leading the Proven Safety Countermeasures Initiative, the Complete Street Stewardship and Oversight Task Force, and various other safety integration, safety culture, and safety system approach initiatives. He's a busy person. Philip has been with FHWA for 14 years, and prior to joining the Office of Safety in October 2019, served as a senior transportation engineer for the Pittsburgh area and oversight of various safety-related activities in the Pennsylvania Division Office. He received his BS in civil engineering from Penn State University and is a registered professional engineer in the state of Pennsylvania. Our second speaker is Florencia Allinger. Florencia is a professional engineer with the California Department of Transportation, where she serves as the Traffic Safety Engineering Branch Chief in the Headquarters Department of Traffic Safety. She is responsible for new products, signing and delineation material, standard plans and specifications for pavement delineation, rumble strips, and Category 1 temporary traffic control devices. And our third speaker is Chris Brooks. Chris is the Michigan Department of Transportation's Work Zone Delivery Engineer. He's been with the department for over 16 years. Chris serves as a technical member on the National Committee, Uniform Safety Traffic Control Devices, Temporary Traffic Control Committee. Chris is an active member of ATSA and ARPA, and is a new member of the National Work Zone Safety Information Clearinghouse's Subject Matter Expert Panel. Chris has a bachelor's degree in civil engineering from Michigan State University. So I'm going to hand it over to our first speaker, Phil.
All right. Thank you, Beth, and hello, everyone. Really appreciate the invite and the opportunity to present on the Proven Safety Countermeasures as part of this year's conference. My hope is that this is not the first time you're hearing about the Proven Safety Countermeasures. Hopefully you've heard about them before this webinar, this session here today. If not, we'll get you caught up, and I'm going to cover actually how you can advance them in your work. And so I'm going to go through a very brief background on the Proven Safety Countermeasures, but the bulk of my presentation will walk through a new guide that we just posted this week on how to implement the PSCs in work zones. And after I'm done, really excited to hear from 2 of your counterparts, Florencia and Chris, on a lot of the great work that they're doing to advance the PSCs in work zones. So if there have been any other federal highway presenters as part of the conference this week, which I'm pretty sure there have been, you've likely seen these disclaimers already. I'm not going to read through them. Essentially, my presentation does not have the force and effect of law, and we don't endorse any products or manufacturers. So I'm not going to read those through here, but in reference will be included as a reference slide should you want to look through those. And so Federal Highway's Proven Safety Countermeasures Initiative was launched in 2008 to give a boost of implementation to several very effective yet very underutilized safety treatments. And after several updates, I'll touch on this very briefly on the next slide, it's now comprised of a collection of 28 countermeasures and strategies. And you'll see they're designed for all different types of users and also all different kinds of roads, whether it be rural, urban, high volume freeways, rural 2-lane roads, signalized crossings, horizontal curves, you name it, we have a proven safety countermeasure to address safety issues or tackle whatever type of facility or address safety for all the users of the transportation system. And so what we've done with this initiative is simplified the countermeasure identification and selection process for agencies and practitioners to this set of highly effective proven safety countermeasures. And so those with limited safety background, they don't have to dig into the research. They don't have to dig through all the literature to find the most effective countermeasures. We've done the work for them and ensure they can address a wide range of safety issues, but also have developed the tools to help them. So I'm not going to go through all this, say what countermeasure was added, and what iteration or what update to the initiative. Rather, this was just to show that it was launched in 2008, and you can see it's updated roughly every 4 to 5 years. And our most recent update occurred in 2021, where we added 8 new countermeasures and updated 1, brought us to the total of 28. It allowed us to establish a new grouping or focus area of countermeasures under speed management. And then we overhauled a lot of our web pages and resources across the full set of proven safety countermeasures. So let's step back a little bit and look at what it means to be a proven safety countermeasure and how we identify and select them. And there's much more to this process, but what I try to do on one slide here is show that simple overview of the main criteria that we use with every update to the initiative and what's the main criteria we use to identify and select proven safety countermeasures. And so for purposes of this initiative, a countermeasure is considered proven by its effectiveness in reducing fatalities and serious injuries. And as one measure of effectiveness, and probably the most common measure, we used a crash modification factor, or CMF, which is used to compute the expected number of crashes after implementing a given countermeasure. And so the process of identifying new countermeasures starts with that comprehensive literature search and review of the CMF Clearinghouse. It's an online repository of over 8,000 crash modification factors, been built over the past decade plus. But at the same time, we know that the research studies that develop CMFs can vary widely in quality and reliability. It depends on a number of different factors: the study design, the number of sites included in the analysis, a lot of different things that can play into the quality and reliability of that study. And for this reason, the clearinghouse includes a system to indicate the dependability and quality of a CMF using a star rating system. The scale of 1 to 5, the more stars, the better quality the CMF. So for this set of countermeasures, we focus on high quality CMFs, those with 4 and 5 star ratings, which indicates they were developed through strong quality research. Now, the PSCs align with and can support agencies with implementation of the safe system principles and elements. And on the left side of the slide here, you'll see the Federal Highway Developed Safe System wheel. On the inside of the circle, we have the 5 safe system elements, and on the outer ring are the 6 safe system principles. Now, if we start to look at a few of the principles, we use this Swiss cheese model or analogy to show how the 5 safe system elements work together, such that if one part fails, there are redundant systems in place. So if we think of each of the 5 safe system elements represented as its own individual slice of Swiss cheese, the holes represent weaknesses in the individual parts of the system. A failure, or in our case here, a fatality or a serious injury crash, can only result when the hole in each slice momentarily aligns, permitting a user to pass through all the holes in the slices. So we have our proven safety countermeasures. NHTSA has their countermeasures that work series. We can use these and implement these to further strengthen each of the individual elements. And if we implement those countermeasures within each of the elements, we can start to plug the holes in the cheese, plug the weaknesses in the system to reduce the risk of a fatality or a serious injury from occurring. Now, understanding these agency challenges, recognizing the initiative now contains 28 countermeasures, we wanted to make sure we were providing the right tools and products to help practitioners find the right solution to their issues. 28 can be quite overwhelming to some agencies, and so we wanted to make sure with the most recent update that we reorganized our web page for the PSCs by each of the different focus areas we have. We also added a search and filter tool to the web page to kind of narrow down that list based on a number of different factors that can be selected in that filter tool. And then one of the staples of this initiative are our one-page fact sheets to give a general overview of what the countermeasure is, the safety effectiveness, the applications, considerations when implementing the countermeasure. But we've also implemented and developed a number of other resources. We put a booklet together, puts all 28 fact sheets under one cover. We have a document that we rolled out earlier this year highlighting rural applications of proven safety countermeasures. And just this week, we posted a new guide. So you can ignore the coming soon. I'll post a link in the chat once I finish up here. And this new guide is on implementing the proven safety countermeasures in work zones. So it describes the application of the safe system principles to work zone planning and design. It goes through and explains those policy and project level implementation strategies to consider and prioritize PSCs in work zones. And then the majority of the guide goes through each of the 28 PSCs. So it gives a general overview and principles of each proven safety countermeasure, a photo, its application to work zones, the safety effectiveness or crash reductions associated with the PSC. And we tried to highlight those specific work zone studies where possible. And then it also includes a number of other resources to assist with implementation. As part of this guide, we also developed a companion desktop reference which touches on how the countermeasure addresses the safe system roadway design hierarchy. I'll touch on that on the next slide here. Its crash reduction ranges or general safety benefits, the relative cost for installation, and its use or applicability of the PSC in work zones. Now, a safe system approach to work zone planning and design decisions aims to anticipate human mistakes and keep impact forces that humans experience in work zone crashes below those that cause death or serious injury. So earlier this year, we developed a safe system roadway design hierarchy. It's a tool to characterize engineering and infrastructure-based countermeasures and strategies relative to their alignment with the safe system approach. So it was developed based on extensive research, those that have adopted the safe system internationally, but it was customized to the US context. So it includes 4 tiers. They're ranged from most effective or most aligned with the safe system approach principles to least aligned or least effective. And it starts with tier 1, and that's to remove severe conflicts. And so that focuses on eliminating those specific high-risk conditions, such as separating road users moving at different speeds, road users moving in different directions in space to minimize those conflicts. And so, for example, workers and pedestrians in a work zone, we can separate them from traffic with a barrier to remove severe conflicts with motor vehicles. Second tier, reduce vehicle speeds. That includes implementing design features and speed management strategies to reduce vehicle speeds. All of this to hopefully or effectively reduce that kinetic energy in a crash should it occur. And so in work zones, we can set appropriate work zone speed limits for all users, implement self-enforcing roadway concepts, traffic calming measures that use those roadway and roadside design elements to prompt reduced vehicle speeds. Now, it also can include things to reduce speeds through regulation, warning, and feedback. So think speed safety cameras, speed feedback signs, pilot car operations. Moving through the hierarchy, tier 3, manage conflicts in time. This assumes that road users will need to occupy the same physical space on the roadway and therefore focuses on creating a safer environment by separating the users in time using traffic control devices. So work zones, these strategies can include traffic signals, pedestrian hybrid beacons, flagging operations, and then also a number of other traffic control devices that assign movement priority. And then the last tier is tier 4, and that's increase attentiveness and awareness. And that focuses on alerting road users to certain types of conflicts so that appropriate action can be taken. It includes a number of things: rumble strips, rumble stripes, visibility enhancements, signing, markings, lighting, different types of strategies, but all of that to inform motorists as they approach and travel through the work zone. So we can think of this as a project-based site assessment tool. Ultimately, the solutions are going to depend on the context, the work zone characteristics, the location, users of the facility, but you can use this as a tool to inform that countermeasure identification and selection. Now, there are a number of different strategies that can be used to implement PSCs from both a policy level and a project level. We have a lot of policies, procedures, and guidelines that are developed and can inform countermeasure selection and mitigation within work zones. Encourage you to look through those. Work zone process reviews, the capability maturity framework. Each state's required to develop a strategic highway safety plan. Many states include an emphasis area for work zones. Look through the other emphasis areas to determine what are the primary safety issues in your state and how the PSCs can be used to support and address those different strategies that are identified in the SHSP. And then last, in the policy level, and probably should be first in this list, is to review work zone crash data. Look at the most common crash types and scenarios that account for fatalities and serious injuries in your work zones. And then down to the project level, we have work zone road safety audits. Those can be performed at any phase of a work zone, whether it be planning, design, deployment, during active work zones. The graphic in the top right shows those 8 major steps of an RSA. And we have work zone inspections. There's a lot of opportunities for coordination, collaboration between the different project stakeholders, and then work zone impacts assessment. So you can see a lot of different opportunities to explore how PSCs can be considered and implemented in work zones. And then the bulk of the guide, as I noted, goes through each of the 28 PSCs. I'm not going to go through each of them in any level of detail, but just wanted to highlight by focus area what we have. 3 PSCs under the speed management grouping. We have 8 PSCs under the PED bike focus area, 6 under roadway departure, 7 under intersection, and then our last grouping includes 4 cross-cutting PSCs. I had underestimated how much time I'd given myself for the presentation, so I had a note I was going to kind of touch on one within each grouping, but in the interest of time and allowing Florencia and Chris to cover ample time to cover their material, I was just going to skip over that. And I just wanted to kind of close with this: where to start. The guide contains a lot of information on where you can start with in terms of considering and prioritizing PSCs for implementation in work zones. Going to note just a few things here. Look at where you are at in terms of implementation. So you can use a scale. We have the everyday count scale from not implemented all the way up to institutionalized. If you're at those lower tiers of implementation, what are the barriers to implementing PSCs within your state? What do your state policies say about the proven safety countermeasures? Looking at leveraging and reviewing and utilizing a lot of the existing information we have. Touched on the strategic highway safety plan. Look at work zone crash data trends. There's a lot of information that's already complete and available and can inform PSC implementation in work zones. And then lastly on the slide here, I have funding. It always comes up under bill. We do have the work zone safety contingency funds. Those may be available to address those unexpected safety concerns in work zones. So I have a link to a fact sheet that was developed just recently. Encourage you to look at that and how it might support PSC implementation in work zones. And then lastly, I think it goes without saying, we are here to help. If there's anything we can do to support you, let us know. And then I had this final graphic basically to show we have a lot of tools at our disposal, a lot of methods, tools to inform countermeasure selection or decision-making at the project level that we all have a role in delivering. Those tools can better allow us to target investments, implementation of the PSCs, all in support of our goal of 0 deaths and serious injuries in our transportation system. And with that, I'd like to thank you for the opportunity to be with you here today. And I think I'll take questions through the chat, and I will turn it over to Florencia to move forward with her presentation.
Thank you. All righty. Okay, so my name is Florencia Ellinger, and I'm going to follow up with Bill on proven safety countermeasures in work zones. So I've been with Caltrans for over 25 years, and I'm under my branch. We currently oversee proven safety countermeasures. However, the majority of my career has been in work zone operations. Chewy was unable to attend with me. He's sick, so I'm filling in for both of us. Out of these proven safety countermeasures, although Caltrans implements all 28, and we're really pushing them all within our districts, there's a few notable ones that we are really seeing promise within the work zones, and I feel are a little bit ahead of the curve. So one being the appropriate speed limits for all road users, the bike lanes and walkways, those kind of go together, and then also lighting. So I'll kind of touch a little bit on all three of these sections. Appropriate speed limits for all road users. So as we just heard Phil say, is speed management very, very important. And it's one of the most important things if we could reduce speed, to help prevent fatalities and serious injuries. So the safe system approach is a big thing here within Caltrans, and we really, really push it through all of our design, construction, everywhere. One thing we've really noticed that was effective within our work zone is what we did is we created a form that it's mandated for every single project. So instead of looking prior to the proven safety countermeasure push and the appropriate speed limit really being showcased, we would look at each project case by case. And would it be helpful to have a reduced speed zone? We didn't really have specific criteria. It was more based on engineering judgment if we should or shouldn't lower the speed limit. Now, every single job, it's an automatic. We will be lowering the speed limit on every single job. The only way we will not be lowering the speed limit is if we fill out this form and we get approval from upper management not to lower it. So instead of leaving it on the engineer on whether should I, we feel it's such an important practice that every single job will have at least a minimum of a 10-mile-per-hour speed reduction on their job. And this form is filled out, whether it is implemented or not. So if it is, we're just saying, yes, we're complying, and they move forward. If it's not, then they have to give justification for why not, and they have to get upper management approval and plead their case on why they feel it's necessary. Again, it is a minimum 10 miles. They could go more if they feel necessary. And it's for both either temporary or 24/7. Some work zones, we have people out there or some sort of closure out there the entirety of the project. Some work zones, maybe it's just daily. So sometimes throughout the construction work area, we may require a speed reduction, but during certain hours that they're actually working, we could require a little bit more, just to make it a little safer for the workers out there. One way to enforce this is by law enforcement presence. So we have in our state what's called COSEEP and MASEEP. So what that is we actually have a contract with our local California Highway Patrol for both COSEEP and MASEEP. And what that is, it's Construction Zone Enhancement Enforcement Program or Maintenance Zone Enhancement Enforcement Program. And we have funds set aside specifically for all projects to be able to have officers on site at all times. And within that, we revisit that and we create a new agreement with them every 3 years. And we call out specific times that it's actually mandatory that you will have a COSEEP or MASEEP officer present at night during specific times. We will get with them and we say we feel it's necessary. That's not the only time they could request it. We have funds available. So on any single job, if we feel it's necessary, we ask for COSEEP or MASEEP. And what we do is the RA will be out there and they'll work with them, and it could look different on every single job. One, we just may need their presence. We just may need them to drive through, make sure they're really enforcing appropriate speed limits, make sure there's no violations, make sure, just see them there. Some speed may be an issue. We may say, okay, we need you to get your LiDAR done. We need you to check speeds, be a little bit more proactive. Throughout the entirety of the job, that could change. We may need them for something else or in different locations, but we work really closely with them, and we feel that this has really, really helped keeping the speed limit down and just keeping violations lower when people just see their vehicle, even if they're not driving, and we just have them sitting like at a specific location. We also remind them with the speed feedback signs out there that, hey, this is what speed you're going. This is what it's supposed to be. This is what you're going. And that tends to kind of wake people up, especially at night when they're driving long areas on these long stretches and they're just kind of going. And then they're like, oh, shoot, I know I've done that before. It's like, wow, we're going pretty fast. Let's kind of try to slow down a bit. So we feel that this has really helped us with the appropriate speed limits within the work zones. We also have bike lanes and walkways. What we've had is a temporary pedestrian access route handbook. And what that is for designers to be like, hey, when should we look at having some sort of pedestrian access route within the area? And how is this going to look when it's in construction? So what is construction supposed to look for? Construction wasn't always like, okay, well, it looks like they could get through. Are we good? Yeah, we're good. Move on. We're following the plan sheet, but now we actually created a checklist. So this checklist, we know how important it is to maintain safe and convenient access for the users. So we've kind of put together this checklist for all jobs to look at and say like, hey, first of all, is the sidewalk closed? Okay, well, are there signs posted? Or there's this, is there that? An actual checklist to go through to make sure we're looking at every single thing. Because as you know, when you're out there on a construction project, you're looking at such big things. Sometimes these smaller things could be missed. So with this checklist, we feel that it's really helped our construction people to be made aware of what to look for. And we have verification that it was looked for and it is there. And if there are any issues, yes, we actually have something stating that, no, this was looked at these dates. We may have photos of it. We may have just, it was compliant, but we actually have that it was actually done out there if anything happens. And this was working so well. What we decided to do is, hey, we're ignoring our bicyclist. So let's create a temporary bicycle accommodation guideline as well. And before, with our bike lanes, if there was a specific bike lane called out, then the project during early stages, the project engineer would see that and they would be like, okay, well, there's an actual bike lane. So now we have to provide another bike lane on this project. So it was really just by a case basis. If there's a bike lane, we're going to look at bikes. If not, then we don't have to do anything. So we're kind of trying to change that. And this guideline is supposed to come out mid-summer next year of 2025. And what this is going to do is every single project, regardless if there's a bike lane or not, let's look at it for bicycle accommodation. So we want to make sure that we are looking at all of our vulnerable road users, whether or not they had an existing bike lane or not. Are there bikes in the area? Do we see people utilizing them? Even if there's a few, what are we going to do to get them through? There doesn't necessarily have to be a called out bike lane for them. It could be like maybe just a bike path. We want to make sure that they could get through. And we want to not just say, okay, sometimes there isn't a way to provide a detour. What else can we do? Can we provide a shuttle for bicyclists? This was a really big thing because especially a lot of avid bicyclists, they have really expensive bikes. They don't want to use a shuttle. What can we do to, help get them through point A through point B? What type of bicyclists do we have that we're trying to accommodate? So we try to put this accommodation guideline together for them to not just look at it closed-minded that there's bikes, we're going to provide an alternate route and call it good. Is really look at what type of bicycle users out there and give them various alternatives on what they could do to get these people from point A to point B as quickly and efficiently as possible and keeping them as safe as possible. Lighting is one other thing that we've really promoted within the work zone. Is just because you're in a work zone and it's temporary doesn't mean to forget about lighting. So for Caltrans, we make sure that we are maintaining illumination during all construction activities, no matter what. So with the exception of a shutdown, if for some reason, that's permitted, or, the final removal of a system, we make sure that even during site preparation, whatever type of work activity towards the end, that our designers are really communicating with our electrical engineers and letting them know the steps of work they have. Because it's not just during the work, it's during the very beginning that, any type of thing that we do could easily impact existing conduit runs or luminaire locations. And sometimes as designers, we're not electrical engineers and we don't really think of that and we don't really see that. We don't really understand that we may be cutting off power. So we make sure our electrical is really involved early on and knowing exactly step by step what we're doing to make sure we're not affecting their conditions, or how we're even our traffic control plans. We make sure that they're familiar with it, because we want to make sure that whatever lighting is required for whatever type of alignment that we're now creating, whether it be temporarily or permanent, we are going to have the correct illumination. So we have an example of one job that was, we had to adjust this this merge point right here. So we automatically require any on and off ramp, merge and divergence points have to be illuminated. So in this project, the traffic was temporarily shifted into the median, which was fine, and it was near the off ramp, and we kept the ramp open, and that ramp stayed illuminated, so it was fine. But what was caught is, well, hey, once you do the realignment, you're now going to create a shift in the divergence point. So we need to eliminate that. How are we going to do it? So we had to work with electrical to make sure, obviously, we wanted the same levels of lighting in that temporary area that we had in the permanent area that's remained open. So in this case, we had to have lighting on wood poles, and we just installed them right there at the temporary divergent point, and everything was right and dandy. So. But that's just an example. Is what we do is we look at every single project, whether it be temporary or permanent, and we really try to make sure that we're getting the right people involved to keep these proven safety countermeasures intact. So thank you.
All righty. Well, thank you for leading those off. So I'm gonna kind of finish it up and close it up here. One of the things that I wanted to do was really get into kind of some of those practical examples and really kind of show how and what we've done in Michigan with those. So it's kind of going to be a little bit more of a lightning round of an overview of seeing all the things that we've done. So some of the things that I'm going to try to cover today are some of the things that we've done with our temporary pavement markings. Getting into that, we'll focus on those a little bit. We've done some different things with traffic regulating or flagging, looking at AFADs, some different things about locations and where to stand. Getting into some of the rumble strips and showing some different applications of how we use those in Michigan here. And then just some other general things that kind of all tie in to the proven safety countermeasures idea. They may not be directly listed, but there's something that we've done that really is kind of those simple low-hanging fruit things that really do add that safety. So it's kind of that, for lack of a better way to put it, that thin layer of Swiss cheese that may not always be utilized or may not be very expensive, but you can toss it out there and it can definitely fill some holes. So before I get that though, let's talk about some innovative proven safety countermeasures. These have been around for a while, but the first one, the shovel, right? Everyone's used a shovel before in their life probably, and I would say it is the most groundbreaking invention in human history. And then the other one would be the whiteboard. Of all the inventions in the past 100 years, the dry erase board has to be the most remarkable. And you know, I was and always do like to tell dad jokes and have the puns in my presentation, but I can't say that this is the cheesiest thing that happened. If you were on yesterday, Brad, we still need to know and have you announce later on who won that 2-pound block of cheese, because that is by far the cheesiest thing that happened, and I don't think we're going to be able to top that with any sort of jokes or anything. But in all honesty, looking at pavement markings, and this is something that we really took a long, deep look at, is our temporary pavement marking operations and their removal and how these were taking place. And I would assume that this looks fairly familiar to anyone that's dealt with temporary tape in the past, where it breaks apart, it's back-breaking work, guys and gals removing that are on, you know, their hands and knees with putty knives, scraping it up. So we really looked at that, and we challenged, our contractor challenged us to challenge industry to come up with some new tape. So what we did is we did a couple tests that were side by side. And what we've done is, as you can see here in the picture, we had them out there, and then the improved tape which has a little bit more on what they call scrim or internal webbing, really lasted longer in areas like this where we have roadway defects, where we have crack sealing, gaps, joints, things like that, where normally someone pulling this up would have to stop and do that. There are a lot of videos online. If you go and Google that, or if you actually me an email, I can get you some. For the sake of time, I didn't want to put one in here, but what happened is we were on a project and basically we found how much faster this tape removal goes. And when we kind of extrapolated that out, what we came down to is that improving this tape and having this removability go faster, for example, 10,000 feet would take about 3 hours to peel with our tape that we were using, and that reduced to about 30 minutes. So we're reducing, just a multitude of worker exposure, and the time that we're out there with lane closures we were reducing. So we figured out that if we were doing 500 traffic switches a season, which is probably low considering all the work that we're doing with fixing the damn roads over here from our standpoint in the state of Michigan, that is definitely something that has been reduced, but it extrapolates about to that over $6 million in savings, and that's just in the user delay cost of having traffic move, not to mention the reduced worker exposure, the risk of not getting hurt, and just not being exposed to traffic. So that improved removability tape really is something that we're really proud of at Michigan and have done and have in place for a while, for a couple seasons now, and have seen a really big reduction. Some of the other things that we do with lane markings is we have started putting in a few years ago now what we're calling lead and lag markings, where leading into a shift or out of a shift on freeways, we're putting a 300-foot segment prior to that shift, and then on non-freeways, we're putting 150 feet. And as you can see here, this is kind of the case study of where this happened is, if you ever have crack seal or overband on your roadways and you get in that morning sun glare, it's kind of hard to tell which line you're supposed to be following. And normally if you would go and have it set up as just skip markings, and then all of a sudden your taper comes in, like the picture on the left that you see here, that's really hard to follow and where that goes. But on the right here, where we had the solid line in place prior to where that lane is shifting over, it really allows you and the motorist to pick up that line and follow that and know where they're going. This is one where we just we missed this in the design because it was still kind of new, but it did a really good job of highlighting just kind of how that, when it's not there, what it looks like, and when it's there, it's kind of one of those unnoticed things, but really preventing those side swipe crashes, merge points, allowing people to stay in the lane really does add a lot of benefit there. A super simple one, but very effective, is signing your access points. We sign things for the motorist and the general public, but a lot of times how we get around on our projects from the construction staff can be difficult. We have a lot of trucks coming into out of our projects, and what we did on some of these that are maybe 5-10 miles long is we put up access point signing. It's a little bit hard to see, but that says access point 4. So could you imagine if you're telling someone that's never been on your job site that's delivering materials, hey, go to this bridge and turn here? Well, you may know that if you're out there every day, but instead just say, hey, enter at access point 4 and then turn north or right, and then we'll be right down there. So just a lot less confusion. Accessing and egressing out of the work zone is a lot safer when you know where you're going and you're prepared. You can slow down, you don't have to slam on your brakes and get over. So just things like that. How we handle our freeway entrance ramps. This is one that we really worked a lot on with making sure and driving this point home of making sure that we have our in place. And we actually state that if you can't have a proper acceleration lane and you do need a stop or yield sign, that we should actually give conditions and think about closing that ramp for a period of time prior to doing that. But we always want to try to get that work done and not see a stop or yield up for longer than 7 days if we do need that in some of those circumstances. But in those cases, we would try to close that and avoid it. And the reason being is we saw a lot of things like this where you're yielding on, you're merging on, and really there's no work going on, so there's no reason to have this closed. They could have built in that taper and matched the existing and gave those motorists those distances, because when you don't do that, even if you have it signed properly with the yield aheads and things like that, but if you don't give them enough space, even sometimes when you do, you still run into the issue of crashes that can occur at points like this. So as you can see here, watch that red car and how they're merging on. And this, I would say, is a well-designed merge ramp. You probably didn't even need to realistically have the yield signs there. You have enough space. But as you can see, that car didn't speed up and merge in, and then you have a crash that takes place. One of the things that I always like to point out in this video too is how long and how far that vehicle travels before it comes to a complete stop. So, you know, there's those areas and making sure we're giving motorists that time and space to merge on safely and get it out there. You know, we need to be aware of that and be thinking about those things when we're setting that up and having that in place. So just making sure, you know, it's not a direct proven safety countermeasure, but making sure we're designing our ramps correctly and giving enough space is definitely something that we can do to make our work zone just that much safer. One of the other things that we've used is a temporary lane separator systems. There's a multitude of different versions that are out there. This is an example on this project. We actually used this for a multi-year project when we were reconstructing a railroad bridge up in northern Michigan, so up in the Upper Peninsula, across US 2 in the Escanaba area. So what we actually had, we had this out there for multiple seasons, and we also had to remove snow around this. And what we realized is it still functioned over the wintertime and things like that. The snowplow drivers just stayed a little bit away of it, and they really salted that. But that really worked from the standpoint of we had a railroad bridge that was a multi-year project, and we really had to maintain traffic over there. And so this allowed us to keep that traffic separated via using this system. This is also something that we've utilized on other bridge projects or just in areas with, you know, a lot of high volume where there might be potential intrusions into the work zone, and you just want that little bit added protection that really does give you a little bit more defined area where motorists can't necessarily cut. They can still cut through because those delineators just pop down, and they would pop back up if they do get hit. But it really does not promote as much as, you know, a space between a drum where someone can try to pull into the parking lot. As you can see, there's a break and the Wendy's driveway is still open there. But up before that, where the work's going on, this would prevent someone from trying to get behind the drum line too early, things like that. So once again, just another tool in that toolbox that really helps define that work zone and kind of, once again, taking those layers of those Swiss cheese and just showing you the different applications that can really help you get to that. Simple but effective, reflective stripes on your temporary signs. A lot of times you're out there at night and sometimes you may not see or be aware of those. Just putting those reflective strips on those panels really do make those signs a lot more visible. And then rumble strips. We have a couple different ways that we use temporary rumble strips. If we're ever changing a stop condition, we have a layout for when we're doing that. So if we have a temporary detour route and we needed to change a free flow intersection to a stop condition, we really want to make sure we're alerting those motorists, especially those ones that have been driving there for years and have never stopped at this intersection. And all of a sudden for the next 3 months, they have to stop there. We're changing the traffic pattern. This really does a good job of highlighting that. We also do this in advance of our work zones on freeways. We now are starting to do this on any projects that are in place longer than 14 days. And we're putting multiple sets out there, and then the spacing does decrease as you get up closer to that work zone. So you kind of get that haptic sound as you're approaching that. These are tamped down to the roadway. They are glued down, so these don't move. Over time, you do have to repair them. They do tend to, for a long, you know, multi-year project or a long season project, they take some damage. And if you have a high volumes of trucks, they do need to get replaced, but you still maintain a lot of the integrity through there as this is going on. And once again, it's just alerting the motorist. As we know, distracted driving is an all-time high, so it really brings their attention back to that work zone. And then we have the temporary portable rumble strips. These are rumble strips that we are using on our non-freeway routes. So our use statement for these are anytime we are doing traffic regulating or flagging for longer than 4 hours on a roadway that is 45 miles per hour or higher, we put 2 sets of 3 of these out. We did some testing with our state police crews at their test track and actually challenged them to try to brake on those and get those to move. There's a multitude of different ways to deploy these and get these out, but really they just do a nice job of alerting that motorist. And if any of you were on the first day of the presentation, one of the fatal crashes that we had in Michigan that I shared, these were not in place, and potentially if these were in place, that vehicle would have came to a stop before striking and killing that regulator. For whatever reason, traffic regulators is a very dangerous position, and we've had, unfortunately, a number of fatalities in the state of Michigan, and I think that's pretty common, unfortunately. So it's really an area and a worker type that we really wanted to protect. So that's why we're starting to utilize these, and we're definitely hopefully going to see a big drastic drop in that. But these do give that motorist that alert. They are not meant for long-term use. They do move occasionally, and you have to go back out there and adjust them. So it's not something you can place and forget like the orange ones. These ones do require kind of that daily maintenance. One of the other things that we're really looking at promoting in Michigan is AFADs, or automated flagger assistant devices. And we are actually starting to put these in contracts and having the contractor have a pay item so they can get compensated for having these out there. That was one of the biggest hurdles that we ran into, is that there really wasn't, there was the extra cost that was on the contractor, and in a low bid environment, some were using them, some weren't. So we've actually started to look at specific projects and really started pushing these and designing them in. And we've gotten a lot of positive feedback from not only our own internal crews that are utilizing these, but industry and at being effective. One of the things that people forget, though, is that when you're using an AFAD, you still have to have an individual out there controlling that. So you still have to have a person for each side. And one thing that is out there is there's this little device. It's basically an anti-fatigue mat called a stand guard. That would go out here, and then that gives that regulator a spot to stand where they have that escape route so they don't kind of wander to and from. And that can be used in conjunction with an AFAD, or that could also just be used by a regulator that is just using a stop slow paddle. It lowers the heat in which they're standing on, so it just makes that person a little bit more aware and takes some of the risk of the elements away from them. So that's something that we've been starting to utilize a lot more in the state as well too. Getting into speed limits, Valencia touched on this a little bit. But one thing that we're doing specifically and in Michigan is we have a where workers present speed limit, and there's always a big discussion on, okay, are the workers actually there? When do I have to slow down? When do I not? So we actually are looking at utilizing digital speed limits with flashing lights when the workers are there at times to really help improve that compliance. And we actually did a study on this through the Smart Work Zone Data Initiative, or SWISD, and Michigan State helped us out with this, and we looked at having these out there and what the presence and how effective these actually are with the speeds in relation to what's going out there. And what we realized is that when they are out there and there was a work truck with a light on, that we actually did see a higher rate of motorist compliance of slowing down to that speed. Now, they're not getting all the way down to 45, but when people were traveling there, but versus when the DSL was active and there wasn't a truck there versus when there was that actual worker there, you can see how effective those signs actually were versus that just being out there. So we really did see a lot of positives with that. So we're working on exploring that a little bit more and digging into that. So we do have some upcoming items with that. And then too, just as we highlight the speed safety cameras, I know this was talked about by Martha, Juan, and Kyle in the first day, but this is just something that really we haven't been able to do yet in Michigan. We're still working on some legislation, but just the numbers that are on those cut sheets that Phil talked about when he was starting really give you an idea of how successful and how accurate those are. The one study and piece of information that I think is great is this case study from Maryland that was done, where it says that 90% decrease in the vehicles which are 12 miles per hour over the work zone speed limit. So you're really taking those high-end offenders, which are likely to cause that crash in your work zone or in those areas, and you're really slowing them down. And I think that is something that we need to focus on and highlight in those areas. You may have, if you saw me present on the commercial motor vehicle side of things, this is something that we're expanding in other areas, is looking at mapping where our workers are via some devices. But I always like to say, that's kind of futuristic, but what can I do today? What can I do tomorrow? If anyone's ever used Waze, if you're out there on a road site, you can go on there, you just click the hazard button. Now I don't even think you need to click the on roadway. This is a little bit older, it's a little bit different now, but you click on road and then you click construction, and that will put you out there and mark you and map you as someone that's out there if you have your device. We are trying to make that all automated. And then two, what we're working on is actually trying to have our worker presence change our speed limit signs through there. And we had a project on our I-96 corridor where we were doing concrete patchwork, or no, sorry, we were doing concrete patchwork and some paving, some other things, where we had digital speed limits set up, workers with sensors, and when they were in those segments, that would then change that sign automatically. And then when they left those segments, those signs would go back up to 60. So those are some of the things that we're working on and testing. And here's an example of that, where once that work crew passed the sign, that would then go to 45 flashing. And then when they left, that would go back up to 60. So we were giving that motorist real and accurate information. So they're more likely to be in compliance when we're giving them valid information. We're doing that through the WZX vehicle X communication. So we're using all those, all that WZX information to do all that. And that is once again connecting into those vehicle dashboards long term. So hopefully in the future that speed limit will be up there and an alert or notification saying that the workers are present. So that was one of the tests we did with GM. And then this once again is another example from the projects from the CNV grants that we talked about on Tuesday, where what is happening right now and can happen is if your vehicles are equipped with a device that is connected, those are actually coming into in-vehicle dash alerts right now today, saying that there's a crew ahead if those companies that you're working with have that connection with the automotive industry. So this is happening today. It's definitely taking off and it's going to be more active. I know there was a session yesterday with Haas and Wanco talking about some of this technology too. So it all kind of blends together and works with what we're doing. And then one of the other things that we're doing is with our work zone lighting, we are taking one of a little bit different approach that I wanted to highlight. Is we actually are looking at, we illuminate our work zone pull-off areas. So as you'll see here, this is just one of our projects where we have one lane each direction. There's not a lot of area to pull off, but we build in emergency pull-off. So if your vehicle breaks down, and then what we did is we actually had those be lit areas, so that way if you do pull over and you do break down, you're not out there in the middle of the night in the dark, and you can actually see and you're safe and you're marked, so that way motorists traveling down that roadway could see you. There is also another smart work zone deployment initiative project that just got selected, and we're right in the kickoff stages of this, where we are going to look at starting to do this and put that out there, and there'll be some new research coming out on the effectiveness of nighttime and worker visibility through there. So now with that, I will shut up here and see if there's any questions that we need to take.
Thanks, Chris, and thanks to Phil and Valencia for being on our panel today. I don't see any questions that have come in. We have like 1 or 2 minutes. If someone wants to put a question in the Q&A box, our panelists can stay on for another couple of minutes.
Beth, the one thing I'd like to add is if anyone does want any information about any of the things that I had shown, is I didn't mention it, but we do have special revisions and details and guidelines for a lot of those different devices to go in our project. So if it is something that you wanted to add, pretty low cost stuff, we have those that we're willing to share and can send any other state. People just shoot me an email and I can get that over to you.
Hey, one quick question for you, all three of you, because you have different perspectives, but what is the greatest reluctance you see from perhaps contractors or DOTs to implement these newer technologies, these proven safety countermeasures? Why are they saying no?
go back to my experience in the division office, and I think it's they go off of what is included in their traffic control plans. So a lot of time it's those upstream factors, the way the work zone is planned and designed. If we're not including pay items or explicit mention of these things, they're not going to go above and beyond to include these things. So I think it's a lot falls on traffic engineers, designers to include and push the envelope a little bit with including some of these innovative low cost countermeasures.
For us, I think everyone's so used to being reactive as opposed to proactive. So although we may provide these elements, even elements that don't require additional funding or anything, it's just really hard to get them to change their attitude. So we've been going district to district and really promoting them and really explaining why it's so important. And we're just really trying to push education throughout our state so they are implemented.
And I would say sometimes it's the overall effect isn't an instantaneous effect. And sometimes it's hard to track your saves and track how effective you are. And that's why I really think once we all start to embrace that safe systems approach a little bit more and really get that ingrained as, yeah, we may not be able to say we saved 10 people's life on this project, but we know overall our crashes are trending in the right direction because we're doing the multitude of fixes. It's really hard to say that, oh, if we do connected work zones, everyone's going to be safer. But if we all start doing connected work zones, we all started doing this technology and that trend is driving downward, that's there. So I think it's just that the cost benefit and really having that trust of the long-term game versus that short-term instantaneous return. I think you really need to sell the overall safe systems approach of the big picture. This is a long goal. We're not going to get there unless we take baby steps. And sometimes those steps may not have immediate results. And I think you need to taper the expectations and make sure everyone's on board. And I think that's the big thing that really the message that you need to have when you're doing this is it's going to work eventually, just give it time.
I have one other question. I'm not sure if we have time to answer it. How about convincing auto manufacturers to create virtual rumble strips in connected vehicles as they approach a work zone or lane closure?
Mr. Foster, I think that would be an awesome idea. I know we've talked about that, and I'm willing to bet 100% that was you that put that question in there. I think having in-vehicle notifications, haptic alerts, and things like that approaching the work zone in the future is definitely something that we can leverage to make things safer.
Thanks, Chris. With that, I'm afraid all good things must come to an end. So I appreciate you guys very much. Our session's about to end, but get ready to click on the next link and join us for worker protection through PPE, which I am boldly demonstrating. Thank you.
Thanks all for tuning in. Thanks, Chris. Thanks, Florencia.
Thank you.